Bismillahirrahmanirrahim. Assalamu-Alaikum. Today I will be discussing with you two important thermal properties of dental materials, which are thermal conductivity and coefficient of thermal expansion. Now let's discuss coefficient of thermal expansion. What is coefficient of thermal expansion? The linear coefficient of thermal expansion is defined as the fractional increase in length of the body for each degree centigrade rise in temperature. So this is a constant which is called coefficient of thermal expansion, and it is basically defined as the change in length over original length of the body for each degree rise in temperature. Now let's see how it is defined in Craig's dental material. It is a change in the length per unit length of the material, which is change in length divided by original length of a material for 1 degree centigrade change in temperature is called linear coefficient of thermal expansion. So it basically deals with change in length of the material with change in temperature. In Phillips, the definition given is the change in length, this is the definition, the change in length per unit of original length of a material when its temperature is raised by 1 degree centigrade or 1 Kelvin. And this is the formula of coefficient of thermal expansion. Now what is the dental application of this property of dental materials? What happens is that in case of filling materials, this is a very good picture which is given, or illustration which is given in Phillips dental, which is given in McCabe dental materials. What happens is that this is the tooth structure and this is the filling material, which is depicted in this diagram by a dotted rhomboid. What happens is that whenever any cold stimulus is applied, for example, if a patient with a metallic filling is having an ice cream or any cold beverage, what would happen that this filling would definitely contract. In case of contraction, there would be a gap created between the filling and the tooth structure. And similarly, when a hot beverage or hot food will be consumed by the patient, this filling material would expand and would produce undue pressure on the tooth structure. Now, if the coefficient of thermal expansion of this filling material is near to the tooth structure, it means that the filling material in the tooth would expand and contract simultaneously. But if the filling material has a very high coefficient of thermal expansion, this means that it would contract a lot and it would expand a lot. And this would cause gap in case of contraction and pressure on the tooth structure in case of expansion. When there would be gap, definitely the fluids, the saliva, the food debris would seep through and they may cause secondary caries. And in case of expansion, they would definitely cause undue stress or pressure on the tooth structure. So this is the importance of this property, coefficient of thermal expansion, that we should know which materials have high coefficient of thermal expansion and which have low, and which have coefficient of thermal expansion near to the tooth structure. Now let's see an example. The value of coefficient of thermal expansion for an amalgam specimen is 25 parts per million. Let's compare this in this table. We can see that enamel has coefficient of thermal expansion of 11.4 and dentine has 8. The silicate cements have coefficient of thermal expansion of 10, which is very much near to the tooth structure. Composites have 25 to 60. Porcelain has 4, which has very low coefficient of thermal expansion. And acrylic resins have a coefficient of thermal expansion of 90. Now let's see what kind of example has Craig Research of dental materials given. It means that the coefficient of thermal expansion of dental waxes, it may range between 300 to 500 into 10 raised to power minus 6. Okay, there's another example of coefficient of thermal expansion. For example, an accurate wax pattern that fits a prepared tooth. It contracts significantly when it is removed from the tooth or a die in a warmer area and then stored in a cooler place. This dimensional change is transferred to a cast metal restoration that is made from the lost wax technique. Okay, so Phillips has given another example of coefficient of thermal expansion and their dental application. Dental waxes have very high coefficient of thermal expansion, and which means that they would definitely contract a lot in cooler areas, in cooler places, and would expand a lot when they are kept in a warmer area. So any wax pattern that is fabricated in a warmer lab would definitely shrink when it is taken to a cooler area, when it is stored in a cooler area, and this may cause some dimensional changes in the final product. So this is another dental application of coefficient of thermal expansion. Now I hope both these properties of dental materials, both the thermal properties of dental materials are quite clear to you, along with their dental applications. Subscribe to this channel for more videos. Jazakallah khair. Thank you so much.